Hey, here's a supplement to your 8.5 notes. In the 8.5 notes, which I think were pretty brief, I did not talk about what to do if the degree of the top was bigger than the degree of the bottom. So, for example, what if you were trying to evaluate that integral? Well, you could factor the bottom and you could think, oh, maybe this is that partial fraction thing. But you can't get your A and your B to cover up to this degree. Partial fractions is going to work when you can factor the bottom and when the top has a degree that is less than, strictly less than, the degree of the bottom. So what do we do here? If degree of the top is greater than or equal to the degree of the bottom, then first we're just going to divide. So it might be a little while since you've done this, but I know you've done this before. We're going to do long division. And it's really not anything to get too stressed out about. Remember that when you're doing these division things, similar to when you're doing synthetic division, we want to leave some spaces there for missing degrees so that things line up nicely. That's the only reason we're doing that. It's not a deal breaker. It doesn't guarantee that things are going to go wrong if you don't leave those spaces. But I think I would recommend it. If you're wondering here, oh, synthetic division, why can't I do that here? You can't do that here because this is not a linear factor. Synthetic division only works when this is a linear factor that you're dividing by. So I think rather than thinking about how many times does x squared minus 4 go into x cubed minus 1, I think really what we're thinking about is what's the thing that I would have to multiply by here so that when I subtract, these things cancel out. So x squared, I'd need an x here, so that x times x squared is going to give me x cubed. And then continuing my multiplication, I would have minus 4x, which I will put here, right? I'm not putting it under here because it doesn't match up with that degree. And be careful, we're subtracting that entire quantity, so easy mistake if you're not being careful to not distribute that negative sign. So let's see, those cancel out by design, and then minus, that gives me 4x, and then whatever that next degree thing, if there is one, I'll drop that down. Okay? And then how many times does x squared go into that? Well, I'm done. That's it. That's my remainder. And you know that you're done when you get something that now has a degree that is strictly less than the degree of the bottom. So what does it mean to have done this? It means that x cubed minus 1 over x squared minus 4 is the same as this plus the remainder over the divisor. Right? And you could check if you wanted to. You could say, well, what would happen if I got a common denominator here? I'd multiply this, the top and the bottom, by x squared minus 4, and this would all simplify to that. But so why is it more advantageous for us now doing calculus that to have it in this form? Because the antiderivative of x is just x squared over 2, and this is now susceptible to the partial fraction method of anti-differentiation. So let's go ahead and finish this problem then. So now my original x cubed minus 1 over x squared minus 4 dx is equal to, it's the same as this. And this, I'm going to now separate. I know that x squared minus 4 is x minus 2, x plus 2. So there's some a and b that I can use to get it to match up to this. So let's see, when I simplify this, I'll have a x plus 2a, getting a common denominator here. That would be missing this. Remember, this piece kind of feels like cross multiplying. It's not really that, but it has that feel all right. And I would need that, once I got my common denominators, to match up to the 4x minus 1. So it must be the a plus b that's giving me the 4. And the 2a minus 2b, it's giving me the minus 1. So however you want to deal with this, many options. I think I just multiply this equation by 2. If I multiply that by 2, that gives me 2a plus 2b equals 8. And then if I add those together, I would get 4a. My 2b minus 2b cancel out. 8 minus 1 is 7. So a is 7 over 4, which means that b would have to be 9 over 4 from this equation here, because a plus b has to equal 4. So there's those. Okay, now I'm ready to rewrite the final rewrite of my integral here. X plus, the a is 7/4, so I'm going to go ahead and put that out front like this, times 1 over x minus 2, because that's just a constant, minus 9, why did I put minus there, plus 9/4 times 1 over x plus 2. And that's an easy calculus problem now. That's x squared over 2 plus 7/4, my constant there, times the natural log of the absolute value of x minus 2, plus 9/4 times the natural log of x plus 2, plus c. There it is. There's your antiderivative. So a little long division first to get that to look to be of the form that we can use partial fractions, and then the partial fractions there. All right.